Hello, everyone, and welcome to day 2 of ICNM. I trust that you're enjoying all of the sessions here. Really excited for this next presenter. My name is Dr. Jasmine Sardana. I am an internal medicine physician and a lifestyle medicine physician practicing at Barnard Medical Center in Washington, D.C. Let me introduce today's speaker, Dr. Kevin Hall. Dr. Hall is a senior investigator at the National Institute of Diabetes, Digestive, and Kidney Disease, one of the National Institutes of Health. His main research interests include the regulation of food intake, macronutrient metabolism, energy balance, and body weight. Dr. Hall develops mathematical models and computer simulations to help design, predict, and interpret the results of clinical research studies conducted by his laboratory to better understand human nutrition and metabolism. Thank you, Dr. Hall, for being with us today. The time is all yours.
Thanks very much for the introduction and for the opportunity to present one of our most recent studies, which actually just wrapped up in March, just before the NIH Clinical Center was forced to close down because of the current crisis that we're in. But fortunately, we were able to put the last subject through, and I'm really excited to share with you some of the results. Manuscript has been posted as a preprint. You'll see a reference to that at the bottom of the slides, and we're in the final stages of peer review, so hopefully by the end of the summer that will be out. So the title of the talk and the title of the study is to discuss differences in ad libitum calorie intake between a plant-based low-fat diet versus an animal-based ketogenic diet. Ad libitum means basically people eating however much or little they want. And so we were really interested in putting head-to-head comparison between the two diets that people recommend very much so to lose body weight and improve their metabolic health. The one that you guys are most familiar with, the plant-based low-fat diet, and then the ones that you're probably also familiar with but have a negative view of, which is the animal-based ketogenic diet. By the way, I don't have any horse in the race here. I'm basically a researcher who's just really interested in answering these kinds of questions in very careful studies. But my lab, as was mentioned in the introduction, is very interested in regulation of body weight and food intake. And so one of the things that we would like to do is to better understand what are the different mechanisms by which the body regulates food intake. And so there's one model of obesity which is basically called the passive overconsumption model of obesity. The idea that if you're eating foods that have a very high calorie density, in other words, many calories per gram or low volume foods, then you'll tend to eat more calories and therefore gain weight. And those foods typically are high in fat. So the things on the left-hand side of this little calorie density chart are filling up your stomach less. The oil, the cheese, the meat that tend to be higher in fat have a higher energy density. They also tend to be lower in fiber. But because they are lower in carbohydrates typically, they tend to result in lower levels of postprandial insulin. In other words, insulin doesn't go up that much after you eat those kinds of foods. On the other side, on the right, the sort of plant-based type of foods that you are more familiar with, those will have a lower energy density. They'll have less calories per gram or per unit volume. They tend to be higher in carbohydrate and higher in fiber, but as a result of the higher carbohydrates, they typically result in higher levels of insulin after eating those meals. And so the passive overconsumption model of obesity says if you eat a higher fat diet, then you will, as a result, to get the same volume or mass of food, you will have to eat more calories, and therefore, you will probably eat in excess of your needs and gain body weight and gain body fat. The other aspect here is that higher fat foods tend to have a relatively low satiety index. In other words, you tend to eat more of those foods at any given time and therefore overconsume calories. And so this is an idea which was discussed by various researchers over the decades, and the idea then would be the lower carb foods should give rise to more energy intake, more obesity. But in more recent years, people have started to turn this on its head a little bit and have a competing model of obesity, something called the carbohydrate insulin model of obesity. And this has been promoted most prominently in recent years by Dr. David Ludwig from Harvard University, who basically poses the problem of obesity in a little bit of a different light. And what he says is that if you look at what makes fat cells fat, one of the things that we know is at a biochemical and endocrine level, insulin is one of the primary regulators of what is keeping fat inside fat cells. In other words, insulin inhibits lipolysis, which is the breakdown of the triglycerides inside fat and release of the free fatty acids into the bloodstream. It also, insulin stimulates uptake of fat from the circulation into fat cells. And so the idea here is that if you want to decrease the amount of fat that's stored in fat cells, maybe you should eat a diet that decreases the amount of insulin that's secreted. And in particular, one of the things that we know is that higher carbohydrate diets, as I discussed in the previous slide, tend to result in more insulin secretion. And the idea of this model is that if you're eating a high carbohydrate diet and you're having a higher level of insulin after meals, maybe that traps the fat inside the fat cells. And that signals to the rest of the body a decrease in circulating metabolic fuels. In other words, the fat is essentially sucking the calories into the fat cells and causing the body to sense a low level of calories in the circulation. And that tells the brain that you're hungry and that therefore you should eat more food. And it should also slow down metabolism in just the same way that starvation slows down metabolism. In other words, because the fat is and the calories are being trapped inside the fat cells because of all the carbs that we're eating causing excess insulin secretion, maybe that tells the brain that, that we should actually decrease our calorie expenditure, slow down metabolic rate. The way that David Ludwig has described this is he says that a high carbohydrate diet produces postprandial hyperinsulinemia, in other words, increased insulin after eating meals. And that promotes deposition of calories in fat cells instead of oxidation in lean tissues. In other words, you're not burning that fat anymore. It gets trapped inside your fat cells and thereby predisposes you to weight gain through increased hunger, slowing of metabolic rate, or both. So this is not violating any of the laws of thermodynamics here, the idea of energy balance. You're still eating more and burning less calories to produce more and more adiposity or getting more and more fat. It's just that the direction of causality is different in this model of obesity. So my lab has been very interested in testing this model of obesity. And one of the things that we've done and many other people have done has been to clamp calories in the diet and just adjust carbohydrate to fat ratios in the diet and ask the question, does that actually change the energy expenditure in the way that would be predicted based on this model? In other words, higher carbohydrate diets leading to decreased energy expenditure, even if you match the calories and the protein in the diet. And we did several studies like that, and we've also done a systematic review and meta-analysis of all of the human studies that have provided people with all of their food, kept the calories constant, and basically just replaced carbs with fat and measured energy expenditure. And what we found was 32 studies that had done these kinds of experiments, and indeed there was a highly statistically significant difference between the calories burned when you're eating a lower carb diet versus a lower fat diet, but it goes in exactly the opposite direction that the carbohydrate insulin model predicts. In other words, you are burning more calories when you're eating a lower fat diet. Now, this is an example of highly statistically significant finding that has almost no clinical meaning, because the magnitude of the effect that we're talking about here is about 28 calories per day. This is, you know, like a bite of an apple or something like that. It's a really, really small amount. What this tells me is that the body is really good that when you match the number of calories in the diet and as well as the amount of protein in the diet, and you can manipulate the ratio of carbs to fat by huge amounts, the number of calories that the body is burning is almost insensitive to this amount. You can detect very small differences, but it's really almost a wash in some sense. So you as efficiently burn the higher carb and higher fat diets once you match for the calories and the protein content of the diets. Okay, so what about the calorie intake, the hunger side of this energy balance equation. So this is the point of our most recent study, is to test those calorie intake predictions of the carbohydrate insulin model. And so what we did was we brought in 20 men and women to the NIH Clinical Center, and they stayed with us for 28 continuous days, where they basically didn't leave. They spent 24 hours a day, 7 days a week for 28 days, and in random order, they received either the first 2 weeks on a low-carb, 10% carbohydrate, 75% fat diet, or a 10% fat, 75% carb diet. And then we switched them after 14 days to the alternate diet. So everybody gets both diets. And what we do is we basically provide them with foods that 3 meals a day and a 7-day rotating menu and unlimited snacks. And we provide them on an individual basis at double the number of calories that they would need to maintain their weight. And the instructions are very simple. Eat as much or as little as you want. And they don't know what we're studying other than effects on their body. They don't know that we're measuring every morsel of food that they eat, but that's exactly what we're doing, because the primary aim of this study is to measure whether or not people consume calories differently on these two diets. Now, the point here is that the low-carb diet is going to give rise to the lower levels of postprandial insulin. Insulin levels should be much lower on that diet. But because of the very high fat content, those meals will be much higher in energy density. And conversely, the low-fat diet will give rise to much higher insulin secretion, but the low-fat content of the high-carb diet will lower the energy density of the food. So we basically have these two models of obesity competing with each other. The carbohydrate insulin model, which predicts that the low-carb diet will lead to decreased calorie intake, and the passive overconsumption model, which suggests that the low-fat diet will lead to decreased energy intake. Okay, so the other thing that I should mention is that the low-carb diet has a variety of animal products. In fact, about 80% of the calories in the meals come from animal products. This is just one day of the diet on the animal-based low-carb menu, starting off with a veggie scramble with a bunch of cheese and cream at the left-hand side. The lunch would be this salad with beef and guacamole and sour cream. And then for dinner, they would have zucchini noodles with a meat and marinara sauce and a side salad. And so again, the idea here is that you're getting about 15% of calories from protein. You're getting 75% of calories from fat and only 10% of calories from carbohydrates, if you were to eat everything here in exactly the proportion. And we actually then matched the amount of non-starchy vegetables that was given for the plant-based low-fat diet. So same amount of non-starchy vegetables, but now 0 animal-based products and very low fat, 10% of calories coming from fat and 75% coming from carbohydrate, and protein was matched at 15%. On the left for breakfast, this would be a blueberry quinoa with some brown sugar. In the middle is a black bean stir fry over basmati rice with a side of apples. And on the right for dinner is a spaghetti with a vegan marinara sauce. So you can get the idea of these different kinds of diets. And we had 7 days that rotated with different meals for these folks so that they didn't get too bored of the diets over time. Okay, so what happened? Well, they indeed consumed, the energy density of the foods that were consumed was 100% greater on the low-carb diet compared to the low-fat diet. So we presented them with these meals that had a very different energy density, and indeed they consumed, the foods that they ended up consuming had a very different energy density, 100% difference between the diets. However, the low-fat diet indeed led to about 60% highly daily insulin secretion. So again, the carbohydrate insulin model predicted that with the higher carb diet, the low-fat diet, you should get more insulin secreted after meals. And indeed, that's what we saw, 60% higher daily insulin secretion. The way that we measure that is by collecting all of the urine from these subjects and a molecule called C-peptide is co-secreted on a one-to-one basis with insulin. But unlike insulin, which is degraded throughout the body, C-peptide remains intact and is only cleared by the kidneys when you urinate. And so just by measuring how much C-peptide is in the urine, you can calculate very, very precisely how much insulin was secreted over the course of the day. And so indeed, we have this situation where we're putting these two models of obesity head to head. The low-fat diet has much higher insulin secretion, so therefore, according to the carbohydrate insulin model, should result in increased hunger and increased energy intake, whereas the low-carb diet had much higher energy density, more calories per gram. And so by the passive overconsumption model, that diet should lead to more calorie intake and body fat gain. So what happened? Oh, the other thing to mention, and apparently an advantage for the lower carbohydrate diets, is that indeed these people became into a state of nutritional ketosis during the low carbohydrate diet. And the other idea of low carb diets is that ketones apparently suppress appetite, and indeed these folks achieved a pretty high level of nutritional ketosis. This is not pathological. They're not going to ketoacidosis here. This is a sort of a normal nutritional ketosis level, getting up towards of about 2 millimolar of beta-hydroxybutyrate in the fasted state. And that should also help the low-carb diets decrease their appetite because ketones are believed to be appetite suppressing. All right, well, what happened? Well, in contrast to the carbohydrate insulin model, there was about a 700 calorie per day reduction in energy intake on the low-fat diet compared to the low-carb diet. So despite the insulin levels being much, much higher on the low-fat diet, and despite the ketone levels going up much, much higher on the low-carb diet, these folks spontaneously ate almost 700 calories per day less on the low-fat diet as compared to the low-carb diet. And that was true for every single individual. In other words, there was nobody who ate more calories on the low-fat diet compared to the low-carb diet. The magnitude of the effect was somewhat different, but you can see that every single individual here, I'm plotting their absolute calorie intake on the low-carb diet versus the low-fat diet. Now remember, this is in random order. It wasn't that they received one diet first and the other diet second every time, but you can see that everybody's data point on the right-hand side for the low-fat diet is lower than that same person on the left-hand side when they're eating the low-carb diet. They ate more at breakfast, lunch, dinner, and their snacks, all highly statistically significant. They actually ate more massive food on the low-fat diet. And that's because of the very large difference in energy density. So they didn't actually eat the same amount of food in kilos. So they ate in excess of 2 kilos of food per day on the low-fat diet and only about 1.5 kilos of food per day on the low-carb diet. And this was highly statistically significant. So they're eating a larger volume and mass of food on the low-fat diet, but still almost 700 calories per day less. We actually measured their eating rate as well. In other words, how long it took them to eat each of their meals. And you can see that the low-fat diet led to people eating faster in terms of grams per minute. But again, because of the very different energy densities, the calorie densities, they were eating slower in terms of calories per minute compared to the low carbohydrate diet. And some folks believe that the sort of eating rate in terms of calories per minute is one of the main drivers of excess calorie intake, because if you're eating those calories very fast before your brain gets a chance to process the fact that you're actually eating food, you may have already overeaten in some sense. And so that's at least one hypothesis for why eating rate might play a role in excess calorie intake. Now, again, this is kind of surprising, but despite them eating 700 calories a day differently, there were no differences in self-reported hunger, satisfaction, fullness, or eating capacity between the diets. So it suggests that people were eating to the same level of suppressing their hunger, to get the same satisfaction, to get the same degree of fullness. And after eating the meals, they felt that they could eat if they wanted to, or if they really tried, they could eat just as much more, but they're basically matching these things, and yet because of the differences between the diets, they ended up eating 700 calories a day more on the low-carb diet compared to the low-fat diet. Interestingly, these folks didn't report any differences in pleasantness of the foods, and they also didn't report any difference in the familiarity of the foods. The latter is kind of by design, because we basically rooted out people who would be very unfamiliar with some of the foods that were being presented, because we didn't want to introduce some sort of neophobia of people saying, oh, I'm not going to eat that because I've never seen it before. The last thing we want when we have people stay with us for 28 continuous days is to drop out. And in fact, we didn't have any dropouts in this study. And we also tried to make the meals as pleasant as possible. We're not trying to make one diet, again, we don't want people to drop out. We want them to like the meals. And so these were both rated equally pleasant, but we didn't tailor it on an individual basis. Now, in terms of what was actually consumed over these 2 weeks, you can see that there's very big differences in the carbohydrate intake, which is the green boxes here, and that's by design. This is in calories per day. Again, with much less carbohydrate intake in the low-carb diet. Now, the point here is that we're measuring each individual food item that these people are eating. So just because we presented them with, the salad with the beef, for example, they could have just eaten the beef and ignored all the salad. And maybe some people did that. But at the end of the day, the carbs and the fat matched more or less with what we presented to people. So it averaged out over the days. However, there was actually significantly lower protein consumed with the lower fat diet, both in terms of an absolute amount as well as in terms of percentage. So despite the percentages and the absolute amounts being presented, being matched between the diets, they ended up consuming a lower protein diet with the low fat diet. Now here's where it gets interesting. So these folks are eating 700 calories a day more on the low-carb diet. That's the red boxes here, or circles here, and that they lost weight faster. At the end of the 14 days on each diet, there was no significant differences in weight loss, but you can see that, within the first week, they're losing weight very rapidly, which, I guess if I was kind of doing this for a weight loss program, that'd be pretty motivating to me, right? I mean, I'm eating a lot of calories and I'm losing weight at a pretty rapid clip. Whereas if I tried the low-fat diet over the course of the first week, I haven't lost any weight at all, which is kind of interesting. And in fact, what we did was we measured the body composition of these people using DEXA to figure out how much of this weight change was coming from body fat mass versus fat-free mass. And in fact, one of the things that was interesting was that the fat-free mass, the non-fat mass of the body, was basically constant in the low-fat diet, but the low-carbohydrate diet resulted in quite a bit of fat-free mass loss. Now, most of this is going to be body fluids and glycogen, which is the stored form of carbohydrate in your body. Also, just the amount of food that you'd been eating sits in your gut. And I showed you before that 0.5 kilo or so more food is eaten every day on the low-fat diet compared to the low-carbohydrate diet. So gastrointestinal contents will be different. But the point here is that the changes in body weight that are being seen with the low-carb diet are not coming from body fat. In fact, body fat changes were not significant over the course of the low-carb diet, but the low-fat diet, and again, these are the same people, are losing body fat consistently throughout the 14 days on the low-fat diet. Now, I just want to share with you some of the exploratory results in terms of fasting blood measures. So fasting plasma triglycerides go somewhat down with the lower carbohydrate diet, and they go up with the low-fat diet. So when you're eating a lot of carbs and you're secreting a lot of insulin, it turns out that your fasting triglycerides tend to go up. Okay, so fasting triglycerides are believed to play a role in cardiovascular risk. So not a great story there for the low-fat diet, and something to consider. Fasting plasma HDL cholesterol goes down in both diets, but goes down by a greater extent with the low-fat diet compared to the low-carbohydrate diet. So again, we think of HDL cholesterol as good, the good cholesterol, but it seems to be going down more with the low-fat diet than the low-carb diet. LDL cholesterol, on the other hand, only goes down significantly with the low-fat diet. It doesn't change from baseline with the low-carb diet. And the particle number, the sort of ApoB containing particles, tends to go up with the low-carb diet, which is a bad sign, and but goes down significantly with the low-fat diet. Fasting plasma Lp(a), which is an independent risk factor for cardiovascular disease, goes down significantly with the low-carb diet, but doesn't change with the low-fat diet, which I thought was kind of interesting. The other interesting thing with our subjects is that, surprisingly, their starting values for Lp(a), despite the fact that these folks are relatively healthy folks to come into the study, are pretty darn high, and in fact are a little bit concerning, and we actually have to call several of these folks back to get their results repeated in a CLIA certified laboratory, because they were surprisingly high. And so, but the one thing that was pretty clear was that the low carbohydrate diet resulted in a decrease in Lp(a), but there was no change with the low fat diet. A marker of inflammation, C-reactive protein, only goes down, and goes down quite substantially with the low fat diet. And again, this is only over 2 weeks on each of these diets. So it's a pretty substantial reduction, indicating a decreased level of inflammation with the low fat diet. We also did an oral glucose tolerance test at the end of each 2-week period. And what you can see is that the same folks at the end of the low-fat diet had much lower levels of glucose after consuming the 75-gram glucose load as compared to the low-carb diet. And so, in fact, several folks became glucose intolerant after the low-carb diet. Now, a lot of folks would say, oh, well, this is clearly because they're becoming insulin resistant. But if you actually do the Matsuda Insulin Sensitivity Index, it was not significantly different between these two diets. It's not even close. What seems to be happening here is that after being on the low carbohydrate diet for a period of time, it's your beta cells that are not secreting enough insulin to keep your glucose levels in the normal range. It's not because you're becoming insulin resistant, at least over this very brief time period. And so it's a little bit of a surprise in some sense. So it's not that they're becoming insulin resistant over 2 weeks of the very high-fat, low-carb, animal-based diet. It just seems that their beta cells haven't yet woken up to a very high carbohydrate load. And indeed, when we look at postprandial glucose, these folks were wearing continuous glucose monitors for the entire duration of the study with us. And so we had 394 meals on the low-fat diet and 368 meals on the low-carb diet. You can see that after meals, blood glucose goes up much higher on the low-fat diet compared to the low-carb diet. And so these folks, when they're on the low-carb diet, because they're eating such low amounts of carbohydrates, they don't really need to produce much insulin. I showed you that it was 60% lower insulin being secreted. So it's maybe not a surprise that the body gets used to not having to produce too much insulin. And then you give them a glucose tolerance test, and it's like, what? I haven't seen this for 2 weeks. And so the beta cells in the pancreas probably are just like, I don't know what to do with this. At least that's one interpretation. But some folks have said that, you know, these very large fluctuations in glucose might be a risk factor for type 2 diabetes or other cardiovascular disease risk. And that's clearly going up much higher after the low-fat diet compared to the low-carb diet by a CGM. We also did meal tolerance tests of meals that matched the macronutrient compositions of the overall diets. And you can see, again, over 6 hours, the glucose levels are going up quite a bit higher on the low-fat diet compared to the low-carb diet. Insulin responses, again, much, much higher on the low-fat diet compared to the low-carb diet. And this was kind of interesting. Plasma lactate goes up much, much higher on the low-fat meal compared to the low-carb meal. And there's a lot of intriguing new research postulating that higher levels of lactate are potentially oncogenic. There's a variety of other hypotheses out there. So it's interesting that the lactate levels go up so much higher on the low-fat diet. In fact, they're going up to levels that would be expected after a bout of pretty intense exercise, which is kind of interesting. So very high levels of lactate after these meals. Fatty acids don't really budge much with the low-carb diet, but they're greatly suppressed, the low-fat diet. And then finally, I told you before that fasting levels of triglycerides are lower with the low-carb diet compared to the low-fat diet. But because you're eating so much fat after on the low-carb diet, postprandial, the values that are appearing after you've eaten the meals are much higher on the low-carb diet compared to the low-fat diet. And so while I told you before that there's some studies suggesting increased risk for higher levels of fasting triglycerides, there's also studies that suggest postprandial triglycerides cause increased risk. So the low-carb diet might win for the fasting, but they clearly lose for the post-meal triglycerides. So what does all this mean? It's kind of interesting, right? So if you're a member of the low-carb keto camp, you'll kind of latch on to the parts that kind of look positive for you. Oh, you can eat 700 more calories and lose more weight over the first week. That's great. This is great news. Or fasting Lp(a) goes down more with the low-carb diet. And so I think that there's positives and positives and negatives for each of these diets. But our primary outcome here was to look at the ad libitum calorie intake. How much do people want to eat? And there, I think it's pretty darn clear that the low-fat, the plant-based low-fat diet led to much spontaneous reductions in calorie intake of almost 700 calories per day, more body fat loss as a result. And yes, there were some other issues that should be kept in mind that you might want to think about, but I think that in terms of the primary outcome of the study, it was pretty darn clear. Now, I wanted to compare this with another study that we published last year, which actually was a very similar design, but in this case, we actually matched the carbs, fat, and protein, sugar, sodium, and fiber, and presented people with the same number of calories. But in one case, coming from almost more than 80% of calories from ultra-processed foods versus an entirely unprocessed diet, whole foods diet. Now, the whole foods diet is not plant-based. Lots of plants there, but it's not plant-based. And again, we were interested in energy intake differences. The point I'd like to make, however, is that the energy densities of the low-carb diet I just presented to you and the ultra-processed diet were quite similar, okay? Whereas the low-fat diet had a very similar energy density to the unprocessed diet in our previous study. You can see various other factors here. The protein was more or less the same across the board, but carbs and fat were obviously quite different. And what's interesting then is to compare what happened in the ultra-processed versus unprocessed diet study compared to what we saw in the low-carb versus low-fat diet study. So here we saw also a pretty big difference in spontaneous calorie intake of about 500 calories per day. But unlike the study I just showed with the animal-based low-carb diet, where they lost weight, when subjects were given the ultra-processed diet, they gained weight. And they lost weight on the unprocessed diet. Now remember, the ultra-processed diet had the same energy density as the low-carb diet. And it's not just coming from fat-free mass. They're also gaining fat mass, okay? So it's not just a fluid thing. They're gaining body fat with the ultra-processed diet that had the same number of calories per gram as the animal-based low-carb ketogenic diet, where those folks, they didn't gain body fat and they lost weight. So there's something over and above just calorie density driving how many calories people are eating. When those calories come from an ultra-processed source, they spontaneously increase calorie intake, gain body weight, and gain body fat, whereas in the case of the animal-based low-carb ketogenic diet, they ended up, which actually has a relatively low amount of ultra-processed foods, only I think it was 25% of calories from ultra-processed foods, they spontaneously lose weight, and at least they don't gain body fat over time. So I think that we're just starting to understand how these changes in our food environment, and this is the way I view these studies. We're bringing these people in for a month at a time and have complete control over their food environment, and they get to choose to eat however much or little as they want, and we can manipulate both the kinds of foods that were being presented to them as well as their nutrient compositions, and we're beginning to see that there are very large effects of the food environment on how much people spontaneously eat, even though we don't even tell them that we're measuring how much they're eating. So with that, I'd like to close and thank all the folks who participated in this research, the folks it takes a huge team of people over the years to conduct these kinds of studies. They're all conducted at the NIH Clinical Center, where we do these kinds of studies in these amazing volunteers who come and stay with us for a month of their life, just for us to poke and prod them and manipulate their food environment in ways that they maybe sometimes don't like. But I thank you for your attention, and I hope we have a few minutes for questions.
Thank you so much, Dr. Hall. That was fascinating. I do want to thank you for your expert time in designing this and bringing this data to us. I think it's fascinating. We do have a couple questions from our audience.
Sure.
So the first question here is, do you have any predictions for longer term metabolic changes on either diet? What about the effects on exercise with these diets?
Yeah, so it's a great question. There's a lot of folks who are very interested in exercise performance over longer periods of time. There is some suggestion that once people adapt to very low carbohydrate ketogenic diets, their exercise performance, after initially deteriorating on those kinds of diets, does improve over time, or at least come back to baseline. But it's very hard to know what happens over long periods of time when people are really sticking to these diets. The way I sort of describe this research to folks is that whereas most nutrition research is studying diet advice, in other words, you kind of advise and support people and really try to get them to stick to certain diets, these are real diet studies. We know these folks eat these foods. There's nowhere else for them to get foods. And so longer term, it's really hard to know what happens. For example, we know that when you give people diet advice trials to stick to very low fat diets compared to very low carb diets, over the long term, there's hardly any effect after a year. On average, they're equivalent. People lose weight, they start to gain it back. And the difference between the two groups in these randomized controlled diet advice trials is like less than a kilo or so. Is it because there's really no difference, or is it because those folks have long since stopped adhering to the diets after a year? I don't know the answer to that question. And so what we hope to do in future studies is design objective biomarkers of trying to figure out degrees of adherence. When we know that there's 100% adherence in our studies, can we measure something in their blood or their urine that will then enable us to, in these diet advice trials, figure out who's really sticking to the diets and then put on a head-to-head comparison with people who are equally adherent. That's, I think, part of the future, and that we'll be able to get at some of these questions over the long term.
That's exciting. Thank you for that. I have another question here. What is worse for cardiovascular health? I wonder if you can speak to this. Postprandial blood glucose or blood lipids?
Yeah, I don't know the answer to that question. I wish I did.
Right.
And I don't think I would say that probably nobody knows the answer to that question for sure, because postprandial measures are so rare. We tend to do these kinds of epidemiological or observational studies looking at risk where we're looking at fasting levels. And so there's a lot of data on that, but there's very limited data on postprandial levels of either glucose or triglycerides for cardiovascular risk. I certainly don't think anybody's tried to do a head-to-head comparison of those things, or even, so I mean, I think we just don't know the answers to that question. What we can say is that probably neither are good. Which one is worse?
Which one is worse?
Is the real question.
Great. Here's another one. Was eating time controlled? Do you think that the difference in fasting triglycerides could have to do with when the foods were last eaten?
Yeah, so there's kind of two questions there. We basically had meal times were standardized so that we presented the food to people. It's in their rooms, the door is open, they have to eat by themselves, and basically we bring the meals in at a standard time, and they have up to 60 minutes to eat their meal.
Okay.
And when they're done, they're instructed to tell the staff to come remove the tray, and then we basically go and the nutrition staff figures out from the leftovers what they ate. So in that sense, the meals are timed. People typically take about 20 to 30 minutes of that 60. I don't think we ever had somebody where we were dragging the tray away at 60 minutes and they were still going. So they're given ample opportunity to eat. The fasting levels are really, they're at least 12 hours fasted. So, so I don't think that this is a carryover effect from previous meals, no.
Great question. Does fiber, next question here, does fiber cause leptin secretion for satiety?
Good question. I don't think so. I mean, fiber typically if any amount that's digested by your microbiota is short-chain fatty acids, essentially, and short-chain fatty acids do not acutely cause increases in leptin. Now, leptin, in fact, glucose and insulin will cause leptin to go up. So we have a separate paper that actually is looking at all of the appetite regulation hormones. And what I'll say is that it's very surprising because they practically all go in the direction that would support eating fewer calories on the low-carb diet, but people clearly didn't do that, which is kind of interesting. So again, it tells us that we have a lot more to learn about what regulates appetite. All the appetite regulation hormones, PYY, ghrelin, GLP-1, leptin, all of those things go in a direction that you would expect that these folks should have eaten less calories on the low-carb diet compared to the low-fat diet, and yet they clearly didn't do so.
All right, so here's another question. This again might be a little bit, but I'll let you take a jab at it. The effect of a low-fat diet on the lipid profile is surprising. Is this significant enough to worry about in patients with hyperlipidemia and many cardiovascular risk factors? And how should I counsel them?
Yeah, so I'm a PhD, not an MD. I don't give diet advice or clinical advice, but what I will say is that it's not just our study, it's a very reproducible finding that lower carbohydrate, higher fat diets lead to lower levels of fasting triglyceride. That has been repeated over and over and over again. And so that aspect is not surprising from our study. I would say that of one of the surprising findings may have been the reduction in Lp(a) that we saw with the lower carb diet that didn't change in the lower fat diet, and so that's something interesting. And the fact that our folks tended to have, at least from a research standpoint, higher levels of Lp(a) was kind of interesting. So I would try to look for the things that are consistent across multiple studies. The fasting triglycerides are pretty clearly different, and that's been very consistently reported.
Perfect. If you're okay with one last final question, it's kind of like a predictive question. The question is, what would you expect to happen differently, if anything, if you had extended your study?
Yeah, great question. I wish I knew. We're thinking about trying to do instead of a in this case was a crossover. What we'd like to do is a parallel design for a longer period of time. and then normalize everybody's calorie intake to, for example, their resting energy expenditure. So we'd like to know the answer to that question. Over very long periods of time, I think that we talked about that before, there doesn't seem to be any net benefit for weight change or body fat change for one diet over another, at least when you just do an advice, try to support people with diet advice, even people who may or may not be highly motivated to stick to one diet over another. So, but I think what we really want to know is when you do have people who really do stick to these diets over long periods of time, what are the differences long term?
Mm-hmm.
And I would say medium term is, months and a year or two. Long term over decades is, a dream, but I think we need better ways of assessing people's diets objectively to do those kinds of analyses.
Well, Dr. Hall, I just want to thank you again for your time, for answering our questions and presenting such fantastic data. Thank you so much for your time, and we're at the end of our session.
Great, thank you. Bye-bye.
Thank you.